In this video I'll show how we can use LLM to convert natural language requests to SQL queries for databases with almost any structure. I think this is a very promising approach for helping business get answers from their own data without involving developers for every time. The implementation is built as standalone NestJS module, but this video is not mainly about the code. It is more about the technical solution and the engineering view of the problem. When our data is stored in a relational database, such as MySQL or PostgreSQL, the primary way to interact with it is through SQL queries. In most business applications, these queries are hidden behind APIs and user interfaces. From the user's perspective, everything looks simple: buttons, filters, tables, and dashboards. But underneath, every possible request has usually been programmed in advance. This means that users are limited to a predefined set of questions the system was designed to answer. Imagine we have a database containing customers, their orders, and the total value of each order. Even though all necessary information already exists, we cannot simply ask which customer has spent the most money. Unless someone has previously implemented the corresponding SQL query, the system has no way to answer that question. And this is the fundamental limitation of traditional applications. They can only answer questions that developers anticipated in advance. From a business perspective, this is a significant limitation. Every new question often requires additional development work. What business really wants is the ability to ask questions in natural language and get answers directly from their data. The challenge is that natural language is vague, while databases are highly structured. My approach is to bridge that gap using AI. The key idea is simple. First, we help the module understand the structure of the database. Then we use that knowledge to translate human questions into safe SQL queries that can be executed against the database. For this experiment, I choose MySQL as the database system and the classic models sample database, which has been distributed by MySQL team for many years as a demonstration dataset for learning SQL and relational database concepts. As the AI model, I will be using GPT 5.4 from OpenAI. Before an LLM can generate SQL, it needs database context. So the module builds a schema snapshot using information schema, the system catalog where relational databases expose their metadata. The module queries 4 information schema tables. These include tables, which provides the list of database tables. Columns describes each table structure. Statistics contains index information. And key column usage defines relationships between tables. Together, these sources provide everything needed to build a complete database schema snapshot. The collected metadata is then transformed into a structured JSON schema snapshot, giving the LLM a clear map of tables, columns, indexes, and relationships for SQL generation. In my schema intelligence service, all schema discovery queries are centralized in one place. I query 4 information schema tables in parallel: tables, columns, statistics, and key column usage. The assembled database schema helps take the raw information schema rows and convert them into a typed database schema object, defined in schema types TS. This creates a consistent JSON structure describing tables, fields, indexes, and relationships, which is later provided to the LLM as database context. The schema snapshot alone is not enough. While it tells the model what tables, columns, and relationships exist in the database, it does not define how SQL should be generated. That responsibility belongs to the system prompt. The system prompt acts as a set of operating rules for the LLM. It defines what the model is allowed to do, what it should avoid, and how the final result should be structured. Here is the system prompt used by the module. It instructs the model to generate only read-only SQL, return structured JSON output, use parameterized queries, avoid risky fields when possible, and respect row limits enforced by the application. Together, the schema snapshot and the system prompt provide both the knowledge and the rules required for reliable SQL generation. The schema snapshot provides the knowledge, while the system prompt provides the rules. At this point, we have everything the model needs: the database schema context and the system prompt. Now we simply add the user's natural language question. We can then send all of this to the LLM and ask it to generate the corresponding SQL query. Generating SQL is only part of the problem. The other part is ensuring that the generated query is safe to execute, which is why the module does not rely solely on prompt instructions and enforces critical safety rules in the backend itself. Only a single read-only query is allowed. The module accepts only select or with statements and rejects semicolons, write operations and multi-statement batches. Row limits are also enforced server-side. If the generated query does not contain a limit clause, the module adds a default one automatically. If the module requests too many rows, the limit is clamped to a configured maximum. Finally, application-level validation is only one layer of protection. The database connection itself should use a MySQL account with select-only permissions, ensuring that even a mail-formed query cannot modify data. Once the generated SQL passes all validation checks, the module executes the query against the database and transforms the result into structured JSON that can be consumed by the client application. To demonstrate the module, I am running it locally using Docker. The module is connected to the classic models sample database. Here you can see the database structure, including customers, orders, products, payments, and the relationships between them. I open Postman and send a natural language question. How many orders have a total amount greater than 49,000? The request is sent directly to my Speech-to-SQL module, which generates a SQL query, validates it, executes it against the database, and returns the result as structured JSON. As you can see, I can retrieve meaningful business data without writing a single line of SQL myself. If I change the amount threshold, the module simply generates a different query and returns the corresponding result exactly as expected. The response also includes useful metadata, such as generated SQL query itself, making it easy to understand how the answer was produced and to debug the generation process if necessary. The main takeaway from this experiment is that AI allows us to interact with databases using natural language instead of SQL. This makes data analysis far more accessible by enabling business users to ask questions directly, without requiring developer to build a new query each time. Of course, this was only a small demonstration on simple sample database. It would be interesting to see how this approach performs on larger real-world datasets. You may also have noticed that the current implementation is fairly expensive in terms of tokens and response time. If you have ideas how to make the module more efficient, faster or more cost-effective, let me know in the comments. If you enjoyed this video, don't forget to like and subscribe. Thanks for watching.